Good morning. Good morning. All right, today we are going to look at our quadratic formula. On Tuesday, we looked at doing things by completing the square, and we're going to do them that way today as well. But we're going to look at it by checking completing the square by doing the quadratic formula. So it's going to do a little bit of both, and tomorrow we're going to continue just reviewing these two topics and getting some more practice. Excuse me, and getting some more practice until we're pretty good at using them. But let's start off by looking at the quadratic formula. It is a formula. If you're going to memorize something, this is what you want to memorize. This will solve all of these every time. It is a complicated looking formula though. So it's saying that x is equal to negative b plus or minus the square root of b squared minus 4 times ac, all divided by 2a. There's a lot going on there. And a lot of this you're probably not going to want to do by hand. You're probably going to want to use your calculator for. But let's go ahead and do a problem with the quadratic formula. And then let's do that same problem again, only using the completing the square method to see how you get the same answers here. So what I'm actually going to look at is this problem here. I'm just going to pull it up. We got b squared plus 4b, that plus 1, plus 1 equals 0, and I want to know what b equals. Now, do not get this confused with the b over here. Remember that these quadratic formula is going to go with ax squared plus bx plus c. It's going to go with this format here. And you're going to have to be able to look at this format and be able to pull out what your a, b, and c is from over here. In this case, our a is going to equal the coefficient to b squared, which we don't have, so it's implied to be 1. So our a is going to be 1. Our b value is our middle term's coefficient, which is 4, keeping in mind that is a positive 4. And our c term is our last constant, which is 1. And you've been pulling these out if you've been doing things the way that I've been doing them for the last chapter as well. So we have an A, we have a B, and we have a C. And all what we're going to do is we're going to plug them into this formula and solve with it. So first it says, in this case, it's going to be B and not X because that's the variable it gives you. But here we're going to have X, or I guess I will say B. For our purposes over here, we're solving for b, so this is going to be b equals this. And we have negative b. Negative b is going to be negative 4 because our b value here is 4, not to be confused with our unknown value. I guess I should just rewrite this. I'm going to change this variable to x. That's all I'm doing. I could have named that anything I wanted. B was just a bad choice because we have a b value here. So here x is going to equal negative b, so that's going to be negative 4 plus or minus the square root of b squared, and again b is 4, so that's 4 squared, minus 4, a, which is 1, so we're going to multiply that by 1, and c, which is also 1, so we're going to multiply that by 1, and that's all being divided by 2 times a. 2, and then a is going to be 1. Once you substitute in, you can just start doing order of operations to simplify things. So my next step is going to look like, I'm going to start with this grouping right here. I guess I can do the denominator while I'm at it. But I'm going to start with this grouping here. I'm going to do things inside or underneath the radical That radical is a grouping sign, so it says, hey, do all this under the radical before you take the square root. So we're going to go ahead and do all that under the radical, and we're also going to do the denominator. The denominator is grouped together as well. So we're going to get -4 plus or minus the square root, and then 4 squared is 16. And then -4 times 1 times 1 is -4, because 4 times 1 is 4, and then times another 1 is 4, and it's negative, so minus that. And we're going to divide all of that by 2 times 1, which is just 2. I can continue reducing underneath the radical here. Hope my face isn't in the way. No, I got some room. I'm going to continue reducing underneath the radical here. So I'm going to get x equals -4 plus or minus the square root, and then 16 minus 4 I can do, which is going to be 12, all divided by 2. And in this case, your radical is going to be kind of tough for you to deal with here. If you want to deal with the radical, you can bring up your calculator and solve that out. But you should also note that I'm actually just going to move this over here because my face is getting in the way. Just move this. Over here. Gives me a little more room. That's all I'm doing there. You can also note that this is going to be equal to -4 divided by 2 plus or minus the square root of 12 divided by 2. So we can just rewrite those with common denominators of 2. Sorry, that's a 12. And then you can do this part here pretty easily. -4 divided by 2 is going to give you, so x is going to equal, -4 divided by 2 gives you -2 plus or minus the square root of 12 over 2. This you are going to want to use your calculator to solve for, and you should be getting 2 answers here, because remember you have the plus and minus version of it. So if I bring up my calculator, I can type this in, I can get negative, turn it on, I can get -2 plus the square root of 12 divided by 2. And I can get that to be x equals -0 point, and I'm going to round this to just the 100th place, 27. And then you also have the negative version of this. So I'm going to solve that, and you can just bring that up again. Go ahead and change that to minus, and we're going to get -3.73. And that was doing it with the quadratic formula. We're going to go ahead and check that work now by doing this by completing the square, which will give you some review of what Tuesdays was like too if you have questions on how to do that still. But I'm going to take my answer and I'm going to move it off to the side here so I remember what it is. Does it fit up there? It fits up there. We're going to fit it up there. And then I'm going to go ahead and give myself some room and solve this by completing the square. So I can leave everything else. And I want to solve this by completing the square. So let's go ahead and do that. If you recall, first thing we're going to do is get this +1 on the other side. So we're going to subtract 1 from both sides. That's going to give you x squared plus 4x. And then you're going to leave a space here because we have to figure out what we're going to add to each to get our perfect square. And to do that, you do b divided by 2 squared. So b is 4 here, so 4 divided by 2 gives you 2, and then squaring it gives you 4. So we're going to add 4 to both sides. Don't forget to do that to both sides. This is just kind of a number you're pulling out. As long as you do it to both sides, it's going to make it true. So don't forget to do it to this side over here as well. This here is now a perfect square, so you can rewrite it, or you can factor it as such. I'm sorry, you got to take the square root of each. So square root of x squared is x, square root of 4 is 2. And you're going to square that. And over here we get -1 plus 4, which gives you a +3. Then you're going to go ahead and take the square root of both sides. to solve for x, and you're going to get x plus 2 equals the positive and negative square root of 3. And then you're going to subtract 2 from this side and subtract 2 from this side, and you're going to get x equals negative 2 plus or minus the square root of 3. And if you bring up your calculator, you can clear all that out, and you get negative 2 plus the square root of 3. So this gives me something good. This gives you your negative 2.7, which is up here. So that one works. And hopefully the other one will work in checkout as well. We do the subtraction version of that. You get your negative 3.73. So you can do it either way. The formula might be a little nicer if you have really ugly numbers, because then you just kind of plug it into your calculator and solve it. But completing the square is, I think, the fun way to do it. So I guess it's personal preference. So let's go ahead and look at another example. Get rid of all that. Don't forget our formula. Again, you got to remember the formula. If you're going to memorize something, this is what you need to memorize. Due to the fact that you're at home, I won't know if you ever memorize this. You can just look it up. And honestly, you're going to have some kind of device to look this up whenever you need it anyways. So let's look at one where we have an a value. See if I can find one. Here's one. Let's do 2x squared minus 15x plus 6 equals 41. Now for the quadratic formula to work, you want this equal to 0. So what we're going to do is we're going to set this equal to 0. In doing so, it's pretty easy to subtract 41 from both sides. So we're going to subtract 41 from both sides and get 2x squared minus 15x plus, and then 6 plus or 6 minus 41 really. 6 minus 41 gives me negative 35. So this is going to become a negative 35, and that's going to equal 0 now. Now that it's set to 0, I can go ahead and plug into here, keeping in mind I have an a value that is 2. I have a b value that is negative 15, and I have a c value that is negative 35. So a little bigger numbers here, but nothing we can't handle. Our formula is very robust. It'll work. So go ahead and plug it in, and we're going to get x equals negative b. Now be careful, because this is already a negative 15, so that's the opposite of b. b is negative 15, so that's a positive 15 there. Plus or minus square root, and again, this is going to be your negative 15 squared, minus 4 times a, which is 2, and times c, which is negative 35, all divided by 2 times a, which is 2. And you can go ahead and start simplifying under the radical. At least that's where I would start. I'll get my calculator up so you can see what I type in. And you could just type in the radical right now and solve it, only I want you to leave things in radicals right now, because if they get to be imaginary numbers, you can still answer it that way. But let's do the squared part first. So first we're going to take negative 15 squared, and remember, if we are squaring the negative, it will be positive in the long run, but remember it needs the parentheses for the calculator. Negative 15 squared equals that. So I'm just come down and start writing things in. I got 15 plus or minus the square root of 225, and then negative 4 times 2, right? Negative 4 times 2, and then we're also multiplying that by a negative 35 times negative 35 gives me a positive 280. That is all being divided by 2 times 2, which is 4. Go ahead and simplify the 250 plus the 280, or 225. So 280 plus 225 gives me that. So x equals 15 plus or minus square root of 505 all over 4. And if you want to, you can break up your denominators. But you can actually just type this in the calculator. You'll note that I have a positive square root here, so I'm going to get a real answer. So I can go ahead and plug that in. I get the plus version, and I want the square root of 505. Don't forget to close your parenthesis because it is grouped together there. I'm going to divide that by 4, and I'm going to get x equals 20.62. And then I want the negative version of it, so I'm going to change this to a minus sign and solve that, and I'm going to get x equals 9.38. I think I messed up something here. Let me look through that one again. Negative 15. Do that right. Oh, that's right. 15 squared is 225. 4 times 2 times 35, and I want the opposite of that. 225 plus 280 gives me 505. Square root of 505 gives me that. 15 plus that gives me that. Divided by 4 gives me 5.6. Why is that different? Let's try that again. 15 plus square root 505 equals that divided by 4 gives me the 9.37. That's a little different. I think my calculator is just not doing order of operations the way I type it in. Minus the square root of 505 gives me that divided by 4 gives me, that's the answer. Yeah, I'm doing everything right except typing it in on the calculator, right? 0.87. That makes more sense. That's what the book is telling me this answer is. Just watch your calculator if you're using it. You can do it in steps as opposed to the whole thing, because then you'll probably get some missed numbers here. I think it's because it wanted to take that division. It took the square root, then it divided it. It didn't divide everything. So I needed a parenthesis here. Minus square root of 505. Close both parentheses and then divided by 4. That gives me, yeah, that's what I did wrong. And then re-enter it as a plus. Yeah, just watch how you type it in the calculator. I missed those parentheses. So be aware of that. Let's go ahead and look at it by completing the square. I don't want the calculator for that right now. Again, we're going to take our answer, move that off to the side here so we remember what they are, and look at this by completing the square in case you need some review with that. Of course, I think it was, did I delete problem? No, problem's over here. So let's look at this by completing the square. First thing you want to do is, because we have the coefficient here, you're going to divide everything by 2, which is going to make things ugly, but that's what we're doing, isn't it? Divide by 2, divide by 2, divide by 2, divide by 2. This becomes x squared minus 15 halves x plus 6 divided by 2. We can actually do that. That's nice. Plus 3 and 41 halves. And then we're going to get the 3 to the other side. So I'm going to subtract 3, I get x squared minus 15 halves x plus something is going to equal, what is this? I need a common denominator, so might as well have left that to 6 over 2 actually. So minus 6 over 2 gives me 41 minus 6 gives me 35 halves. It's looking right so far to me. So then again, you want that term that'll make this a perfect square, which is going to be your b term, which is negative 15 halves divided by 2 squared. And that's just going to be negative 15 squared. Because again, you're going to multiply by the reciprocal. So that's going to be negative 15 squared, which gives you, we just did negative 15 squared, that's your 225. You should note that number is familiar. So we're going to add 225 to this side, and that's going to make it a perfect square, but you're going to add it to this side as well. So here we get, you can do it as the perfect square. Don't let that fraction confuse you, because it is just going to be x minus 15 squared. Right? You're just going to take the square root of this, which we already found, and you take the square root of this, and when it's a perfect square, the middle term kind of cancels out. So you don't need it, but don't forget to add this part over here. So here we're going to need to find common denominators. Add, so 35, 225 times 2 is 450 plus the 35 gives us 485 over 2. Go ahead and take the square root of both sides, and you're going to get x minus 15 equals plus or minus. Don't think a square root of either of that is going to do any good. You could play with your radical, but I'm not sure you know how to do that yet. 485 over 2. And then you're just going to add 15 to it. So plus 15, so you have 15 over here. So you're getting, I'll put it on this one, you're getting 15 plus the square root of 485 divided by 2. And that's not working, right? I'm messing something up here. Where did I go wrong? I'm not sure where I'm going wrong here. Oh, that's where I'm going wrong. I did that division wrong. Is that what I'm looking at? I'm doing b divided by 2 squared. Isn't 15? Negative 15 divided by 2, all divided by 2. Negative 15 divided by 2, divided by 2. I should have did divided by 2 squared there, that's why. I multiplied, it stays on the denominator. And then I square that, and I get that ugly number. So I should be adding 14.0625 to both sides, which is going to change a lot of things. So let's just go back to that step. And we get, oh, let's see, we divided everything by 2. I'm going to leave that as 6 halves. 41 over 2, so then I can subtract 6 halves from both sides. And I'm left with x squared minus 15 squared plus whatever my c value is, which is going to be this 14.625 now. Minus 41 minus 6 still gives me the 35 over 2. I am then going to add that 14.625. So I want to add it like that. I lost the fraction for that, so I'm going to do everything in fraction and decimals now. That's all. 17.5, and then that doesn't matter. The square root of this should give me that negative 3.5 there, right? Square root of 14.0625 should give me, yeah. And minus 3.75 squared equals 17.5 plus 14.020625, 31.5625. Take the square root of that side, take the square root of that side, and you get x minus 3.75 equals plus or minus the square root of 31.5625, and you're going to be adding 3.75 to that side. So we get 3.75 plus square root of that, and there's your 9.37, and you get 3.75 minus the square root of that, and there's your, that's not your answer. Did I change the right thing? Oh, that's because I put the answer in wrong. 3.75 minus the square root of 31.5625. And there's your answer. So I guess the decimal worked out that way. But yeah, either way works. You can use one way to check the other way or not. We can do another one. That one I kind of messed up on one little bit there and screwed a lot up. So let's do another one. Again, there's your quadratic formula. Let's do 3d squared minus 24d equals 3. In this case, I have to move my 3 over to get the equal to 0, but again, you still want to set it equal to 0 before you solve, plug into your quadratic formula. So here we're going to get, well, subtract 3 from that side, subtract 3 from that side, you get 3d squared minus 24d minus 3 equals 0. That is a 4. And then you got your a equals 3, b equals negative 24, and c equals negative 3. And go ahead and plug into this. Negative b is a positive 24 plus or minus square root of b squared, which is negative 24 squared, minus 4 times a, which is 3, times c, which is negative 3, all divided by 2 times a, which is 3. So go ahead and simplify underneath the radical and simplify the denominator. 24 plus or minus square root of negative 24 squared. 24 squared is 576 minus 4 times 3 is 12. 12 times 3 is 36. And that is negative still, correct? Negative times that, no, that's positive. It's positive, and 2 times 3 gives you 6. Continue reducing underneath that radical as best you can. So 576 plus 36 gives us 612 over 6. You can separate your denominators if you want. I guess I should just rewrite it so you can see it. Equals 24 over 6 plus or minus the square root of 612 over 6. In this case, you can simplify the 24 over 6. So x equals, is it 4 plus or minus the square root of 612 over 6. I'll show you on this calculator, I guess. 4 plus, sorry, don't make the same mistake I did before. Get that parenthesis in there. You're gonna, actually we don't need it here. We're just gonna do the order of operations. We'll do the square root of 612 divided by 6 gives us that, and then you want 4 plus that answer. It's 4 times that answer, great. Get that answer, and I want 4 plus that answer. Gives you x equals 14.1-ish. I'm checking my book because that doesn't make sense either. No, I'm not getting the right answer there either. I'm not having good luck with this formula today. What if I didn't separate the 6? It's 24 plus square root of 612 and all of that divided by 6 gives me 8.12. I think that makes more sense. Yeah, 8.12. 8.12, and then the other version is the negative version. Just gives me negative 0.12. That makes more sense to me. So just watch the calculator work. It's not being friendly to me today. How did I screw that up? Yeah, it's not working because I took that 4 with it. Divide that by 6. Add 4 to it. That's giving it. And then square root of 612. That, make it negative. Divide it by 6. Gives you that. And then 4 minus. I already did the negative. I don't want to do that. It gives you that. Yeah, I don't know why it was working that time. It wasn't the other time. But that's your answers. Again, you're just plugging into the formula and you're solving. We can look at some from your homework now. I can do one more from your homework. And we will review. We're not going to do anything new tomorrow. We're just going to get more examples of it until we get good at it. And you can see it's been a while for me as well. So. Actually, I have all that saved. There's your formula. Let's look at your homework. Your homework is page 550. I don't remember what I gave you. One through 15. So let's look at number 1. It says 2x squared plus 5x plus 3 equals 0. Your numbers are going to be a little easier here. But we do have an a value here, which is 2. We have a b value, which is 5. And we have a c value, which is 3. Again, a comes from your first term, b coefficient of your second term, c is your constant. Plug it in, you get x equals negative 5, because b is negative here, so opposite of 5, plus or minus the square root of 5 squared minus 4 times a, which is 2, times c, which is 3, all divided by 2a, which is 2. So again, clean up as best you can. We can get x equals negative 5 plus or minus the square root of 5 squared is 25. Negative 4 times 2 is negative 8. Negative 8 times 3 gives you negative 24, all divided by 2 times 2 is 4. Here we can simplify the radical a little more. Plus or minus the square root of 1. 25 minus 24 is 1, all divided by 4. Square root of 1 you can do, sorry. X equals negative 5 plus or minus 1 over 4. Negative 5, my head in the way. No, not yet. Negative 5 plus 1 gives you negative 4 over 4, which equals 1, and negative 5 minus 1 gives you negative 6 over 4, which equals 6 divided by 4 is 2. No. 6 divided by 4 is not 2. 6 divided by 3 is 2. 6 divided by 4 is, I'm doing horrible here. It's 1.5. And this is negative, because that's a -4. So there you go, if that's visible to you. Just don't forget the plus or minus takes it both ways. So with that, give it a shot. We're going to do more practice with it tomorrow, but it's just going to come with practice. The more you do it, the better you're going to get at it, and it's just practice, practice, practice from there on out. Feel free to use things, use your calculator. Your calculator doesn't do imaginary numbers by default if you're using a calculator like this, so if you do like the square root, actually mine might be set to it. If you're ever finding yourself doing the square root of a negative number, yeah, mine's set to it. Yours is probably not set to it. You ever find yourself doing the square root of a negative number, you get no real answers come up on your calculator. So there is a chance that you will get no real answers for these. Just be aware of it. Or if you wanted to, you can just change it to do imaginary numbers and get the imaginary number answer. You just get an I in there. So you get this I. So this is basically saying 1.732050888 times the square root of -1. But you don't need to know any of that right now. So with that, I'm going to end it. You have questions, save them for tomorrow or email me. But again, tomorrow we're not going to do anything new. We're just going to be doing more practice, practice, and practice. So thanks for tuning in, and good luck with it. Make sure you type things correctly in your calculator, the best you can if you are using a calculator. If you want to leave things as a radical, that's fine as well. I can figure out radicals pretty easily. So let me know, and I'll talk to you tomorrow.